SAT 22 for week 9. Let's take a look at our question. In triangle ABC, angle B is a right angle. The length of side AB is 10 square root 37, and the length of side BC is 24 root 37. Strange numbers there. What is the length of side AC? Well, according to our pie graph here, almost 70% of us chose answer choice B, which was the correct answer. And in second and third place, actually tied for second place, is C and D. Let's see if we can get to the bottom of that when we go over the solution. How did we find our solution? Once again, Desmos is on top. Nearly 50% of us used Desmos, where we have a pretty close split between phoning a friend and doing it by hand. How are we going to do it? Spoiler, we're probably going to just do it by hand with no technology. And then finally, we thought this was a mid-level question here. 63 people saying that it was about medium. 3 is skewed a little bit towards the easier side. All right, let's dive right into the solution here. So strategy, first thing, sketch a picture. So we got ourselves a right triangle, and it tells us the right angle is labeled a B, and the other two doesn't really matter. We can put an A over here, and we can put a C over there. There we go. We just need our right angle to be B. And then let's label our pieces. And the reason why this is important is because right triangle, probably Pythagorean theorem. Don't want to mix up the hypotenuse with something else. AB is 10 square root 37. And BC is 24 square root 37. There we go. And then, of course, we have our classic hypotenuse C. Now, yes, you can use the Pythagorean theorem on this one. That's exactly what you're supposed to do, right? You go, oh, I've got myself a right triangle, so I know a squared plus b squared is equal to c squared. But here's what I'm going to show you. This is an example of what's called a Pythagorean triple. Pythagorean triple. And Pythagorean triples are whole numbers that work in the Pythagorean formula. For example, the most classic one people know about is 3, 4, 5. So, for example, 3 squared plus 4 squared is equal to 5 squared. Just working this out, 9 plus 16 equals 25. That's a check. Okay, so how these things are so useful is that if you recognize a 3, 4, 5 right triangle, you actually recognize about, I'm going to go with like an infinite number of them, because all you got to do is just dilate our side lengths. So we're basically making a similar triangle to this one, just with bigger or smaller sides proportionally. So for example, if I multiply all of these things by 2, I have a 2 times 3, a 2 times 4, a 2 times 5, then I have a 6, 8, and 10. And guess what? This also is a Pythagorean triple. So I have a 6 squared plus an 8 squared is equal to 10 squared, just to show you. 36 plus 64 is in fact equal to 100. Okay? And so the more of these Pythagorean triples that you can recognize, the faster it is to solve some of these problems and saving time. Kind of key on PSAT and SAT. So here, let me give you a list of these Pythagorean triples real quick. This will be in a lesson that we do at some point this year. Here we go. So these Pythagorean triples, so here's like a picture of some of these things. You got your 3, 4, 5, 5, 12, 13, and 8, 15, 17, 7, 24, 25. This is not all of them. However, these are the most commonly used ones on things like SAT. And what this slide is showing you here is that if you just take multiples of all your sides, you're just basically dilating your figure, making another right triangle with proportional side lengths, which are also Pythagorean triples. And then, oh, look at this big old list. So this is a list of primitive Pythagorean triples. That means that they don't have any common factor other than 1. And the hypotenuse here is less than 100. So this is a complete list, but you can take all of these things and then multiply it by some sort of scale factor and make a whole bunch more. Okay, all of that to show you how fast it would be if you recognize this to solve this question. Here, let me show you. So what I want to do is I want to check to see what the common factor is between these two things. Well, obviously I can see that they both have a square root of 37 in it. Not only that, they're both even as far as the coefficients here. So really what it is 2 square root 37, and this one is being multiplied times 12, right? Because the 2 times the 12 is 24. All right, and then down here at the bottom, we have 2 square root 37, and this one's being multiplied times 5, because again, 2 times 5 is equal to this 10. And the thing that I want to highlight for you is 5, 12, and then I want to complete my Pythagorean triple. Completing that Pythagorean triple is 5, 12, 13. I'll pull that slide back up here for you. So 5, 12, 13 is this guy that's right there. Another really common Pythagorean triple, which means that my answer for my hypotenuse should be 2 square root of 37. That's what I'm dilating my shape by. And then I multiply that times the 13. Now, of course, this is exactly one of the answer choices. I just have to simplify here, multiplying the 2 and the 13, and then I get my 26 square root of 37, which is, in fact, answer choice B. Boop, 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 boop. Now, is this how you did it? Probably not. I would suggest that most of you just threw this thing straight into the calculator by going, my A, let's make that 10 squared is 37 squared plus my B, 24 square root 37. And we're squaring that and equaling C squared. So one of the things that you could do, obviously, is just throw all of this straight into Desmos and take your square root, of course, and then all you have to do is compare that to the 4 answer choices. And if you do this in order, you'll get it pretty quickly since this one was answer choice B. Now, there's another way to do it also by hand, if you know your perfect squares, which goes like this. So whenever I square this 10 square root of 37, I know that I'm going to square the 10, which is 100. And when I square the square root of 37, the square and the square root cancel out. So I have 100 square root, no, times 37. And don't multiply them, just leave it just like that. Plus, and then the same thing's going to happen over here. So 24 is going to get squared, and the square root of 37 is going to get squared. I think that's 24. 24 squared is like 476. Let me just double check that. 576. 576. Okay. 576, and then times 37 is equal to C squared. Okay, so whenever I add these up, I'm going to treat this thing like it's an X. Like this one's an X. And I've got 100 of these plus 576 of these things to give me 676 of these, where these are the 37s equals C squared. And then, of course, we know that we're taking the square roots, And if I am not mistaken, over here, the square root of 676 is 26, and then we would have our square root of 37. Let's just double check that real quick. Let's see, 20, no, go to the next line. 26 squared, yeah, 676. So there you go. There's another way to do it. Again, this is assuming that you didn't know about the Pythagorean triples as a shortcut, which I'm telling you, folks, is in fact the way to go. All right, so that should wrap up this video on, using the Pythagorean theorem or shortcuts with Pythagorean triples.